Can you see? Is it clear in the back? Okay, perfect. So I would like to start with this, and this. Yes, if we run into difficulties, I'll explain them again, but I hope that one time today will be good enough, and then we can move on from here. Anyone remembers what a plus b squared equals to?
A squared plus AB plus B squared.
Go ahead.
A squared plus 2AB plus
You said a squared plus?
2AB.
This is one of the special products, and in previous classes this was discussed extensively, but since we are not thinking in those terms all the time, I understand why we may be a little bit shaky on this, but moving forward, I hope that we remember. Do we know how we get this? Do we know why there is a 2 in here? Is that a yes or a no?
Yes.
Okay. Do I need to explain this? No. What about the other one, the next one?
A squared minus 2AB minus B squared.
And what about the last one?
A squared minus B squared.
Correct. So this is our agreement. Moving forward, we will remember these 3 special products. This is the difference of squares, and these are trinomials, right? So every time I have to square a binomial, what do I get as a result? Very good. So I just want to make sure that moving forward we avoid something like this. Correct? Okay. Good. So that was the first thing I wanted to mention. And now let's go over, I printed out a skills assessment from WebAssign, as I mentioned. But some of you came in late and a few minutes late, and I don't know if you caught this. So this document is what I saw, or what WebAssign gave me as an example of the skills assessment. I just simply printed it out so we can talk about it. Your responsibility is to go home and redo this in WebAssign between now and Thursday, as long as we finish it today. If we don't finish it today, just look at the problems that we covered in class and leave the rest for next time, okay? So let's see how much we can accomplish. Now, I will also ask you to read this and say, oh, this is too easy, move on. If you don't say anything, then we'll cover it together. So let's start with the first problem. You all have this, right? Everyone? Mm-hmm. Okay, perfect. So find the equation for the line that passes through the point and is parallel to the line. Everything here, all this review, is useful for what we are going to cover in this class. So what would you say about this? Is it a yes or a no? We work on it? Yes. We don't work on it? No. Yes. Okay, perfect. So we have a point. So the point is 2, -2. And the line that passes through this point is parallel to 2x minus 4y equals 1. We are asked to find the equation of that line. Can you see from here? You want to go closer? You feel like it? Please come closer. Okay, so the scenario here is, or the idea is, that there is a line whose equation is unknown, but we do have 2 pieces of information here. We know that it passes through the point 2, -2, and is parallel to this line whose equation is 2x minus 4y equals 1. This is what we know. We want to find the equation of the unknown line. Now, we do have two equations for the line. For any line, we have y equals
X plus B.
thank you very much. And we have y minus y1 equals
X2.
very good. So the first one is called slope, y-intercept, or simply slope-intercept form. And the second one is called point slope form. Point slope form. Do we have the y-intercept? Is this the y-intercept? No. The y-intercept will be 0, comma a number. 0, comma b is the y-intercept. But we don't have that. We don't have 0, comma a number. So we will not use y equals mx plus b. We will use y1, y minus y1 equals the slope times x minus x1. So y minus y1, the slope x minus x1. And we have 2 and negative 2. This is x1, y1. x1 is 2, y1 is negative 2. But we're missing a piece of the puzzle. How do I get this slope? Is there any way I could get the slope?
Solve the y.
Very good. I take this given equation 2x minus 4y equals 1 and solve for y. Why am I solving for y? Right. So I have negative 4y. We subtract 2x. And we will divide both sides by. So then we get y equals negative 2 divided by negative 4. Negative 2 divided by negative 4. Very good. 1/2 x minus 1/4. And the slope of this, let's call it m2, m sub 2, is very good. If the slope of the second line is 1/2, what is the slope of the first line? 1/2. How do we know? Because they are parallel. Any questions from me, please? Is this okay so far? We do have to solve for y, however. So we replace the slope by 1/2. And we have y plus 2 equals 1/2 x minus 2. We distribute. We get 1/2 x minus 1. And then we subtract 2. So y equals 1/2 x minus 3. Also written, I don't know why, when I did not expect the solutions to be there. I didn't even look. So the answers are there, not the solution, but the answer is there. I would never really present, I shouldn't say never, but I think that the best presentation is 1/2 x, so we can identify the slope, but x over 2 minus 3 is still perfect. Any questions on this problem? Any questions? Okay, so you're going to have something similar to work on. Here's the next one. We are asked to find the values of, to determine, say the value of f of negative 1. So what does this mean? What is given in the question? X, indeed. So remember, x equals negative 1 is a vertical line. So I draw, so the origin is right here. I draw, or imagine I draw a vertical line, x equals negative 1. It crosses the graph in this point, and I will read the y value. What would you say the y value is?
2,
Negative 2. Good. Then we're asked to find f of 2. I will perform the same operation. I will draw a vertical line. It crosses somewhere here, and I will estimate this value. If you say 2.75, I'll accept it. If you say 2.9, I'll have to accept it. If you say 2.8, I'll accept it too. So it's an approximation. Whatever you say in that range, I will accept it. I don't care what they say. So if you get something like this on a test, so what will you write to write? Okay, 2.8. For what values of f of x is f of x equals -1? What is given now?
1.
Yes, this means y equals -1, but y equals -1 is what type of line? Very good. So at -1, I draw a horizontal line, and I see it crosses the function in 2 different points, and I will read the x value for those points. So then from here I will write x equals, if this is 0, -1, -2, and I will also write x equals, perfect. Estimate the values of x for such that f of x is 0. So what are we asked to determine now when we are told f of x is 0? At least 2 options that you should keep in mind. The zeros of f of x. So when we are solving the equation f of x equals 0, we are finding the zeros of f of x. What is the other way of saying it? Find the right. Of course. X-intercepts. Of course. And also a third option is find the solutions of the equation. That's true. But specific names for this, the zeros, we are finding the zeros of f of x, or we are finding the x-intercept of f of x. So going back, we're asked to find where is x whenever y is 0. So here's the x-axis, and I see 2 points. I see this point, and I see this point. And whatever you say, I'm going to say it's okay, as long as it's in a close enough range. What will you say?
Maybe 2.5 for the left.
Good. So x equals -2.5, and for the positive one, I don't know how they came up with 0.3. It could be 4.2.5. Whatever you say, I'll accept it. But then a good approximation. What will you say? It's between 0 and 1, closer to 0.
0.3.
Okay, fine. State the domain and range for this function. So we notice that this function starts with a full point and ends with a full point. That is a crucial notice, right? So then I will say, bless you, I will say that this is the domain of this function on the x-axis, of course. And then I will say that this is the range, domain and range. Can anyone identify either one for us? So we will say domain and range. So if this is 0, -1, -2, -3, so it's between -3 and 3, very good, with brackets. And the minimum value is at -2, appears to be, and it goes up to 1, 2, 3, +3. So I will write -2 to 3. Is this okay? Any questions? Okay. Let's look at the next one. Is it a yes? Finding a domain? Yes, okay, let's do this. Perfect. So then this is f of x equals 2x plus 1 over x squared plus x minus 30. What type of function is this? We need the name. What is the name?
Rational.
Excellent. It's a ratio of two polynomials. Of course, it's a rational function. Rational function. Thank you. Good. What could go wrong with a rational function?
Could have no solution.
We're not solving anything right now.
The denominator could have a factor that's equivalent to the numerator.
Perfect. In a way. But my question is different. But your point is very well taken, and I'll explain in a moment what it is. That I think it's a good answer. Why is it a good answer? What can go wrong with a rational function is the denominator could be 0. And that would be a catastrophe, quote unquote. Why? Because division by 0, yes, division by 0, we say does not exist, but we like to use the word undefined. Is undefined. Division by 0 is undefined. So that's what could go wrong. Now, if a function, because I want to address what your colleague said for one second. If we have a function like this, x minus 1, x plus 2, over x minus 2, and x minus 1, yes, if the factor exists at top and bottom, still the function is undefined at 1, and it would have a hole. Once this goes away, then it will remain with a vertical asymptote at 2. But that's not the issue. The issue is that this function will not exist for x equals 1 or for x equals 2, even if we remove that factor. Because restrictions have to be stated before we simplify. So it doesn't make any difference if it disappears or not. The restrictions are stated on the raw function. Okay, so coming back to our example, what do you think we have to do next? I'm going to copy it here. You don't have to copy it again. So can anyone factor the denominator for us?
Parentheses x plus x. X minus.
Very good. So there are two possible restrictions here. And what are they? The restriction from here is that x could never be excellent. And the restriction from here is that x could never be exactly. Do we understand this? Don't be shy. Please raise your hand if it's not clear. Is this okay? Are you with me? Okay. So this is wonderful, but this is not what the question is asking us. The problem is asking us to find a domain. So we have to present this in interval notation. In plain English, everything but -6 and 5. But in interval notation, from -infinity to and union, parentheses means it's not included. Union -6 to 5, parentheses means is not included. Union 5 to infinity. Now the next problem, any questions on the previous one? What type of function is the second one? And we can no longer say rational. That's good. No. It's a combination of two functions. A rational function is a ratio of two functions. The top one is a cube root, and the denominator is a polynomial. So a cube root over a polynomial has no name. It's just a combo function. But I do have two possible situations here. I need to make sure that the radical exists. Have to make sure of that. And also I have to make sure that the denominator is not 0. So this is a more complex, slightly more complicated situation. In the previous case, the numerator and the denominator were both polynomials, and the only danger was the denominator to be 0. But here, there are two possible dangers. The denominator could be 0, and the numerator may not be defined. So let's start with the denominator. Are there any restrictions on x squared plus 1? In other words, x squared plus 1 cannot be 0. Why?
Because if you plugged in 0, you still have that.
Right. So no matter what you put, this is always a positive number. Plus 1 will always be a number greater than 0 strictly. So it will never be 0. So there are no restrictions from the denominator. The denominator is always positive, never 0. What about the numerator? No restrictions on the numerator. Why? Because this is a cube root, or in other words, any odd index has positive 0 or negative underneath. No restrictions on odd, indices, on radicals with odd indices. No restrictions. So then what will you say about function g? What is its domain?
All real numbers.
Yes. Indeed. Good. Now, this next problem, I would have presented it no matter what, even if you said, no, it's easy, we don't need it. Because this is a totally different story. This is a function composition, or I should say a sum of two functions, to be exact. So the next one is h of x, the square root of 7 minus x plus the square root of x squared minus 1. So if you want, this is function f1 and this is function f2. So this is a sum of two functions. So if these two functions do not have a common domain, if they do not have a common domain, we cannot create this function whatsoever. In other words, if one of them is defined, let's say, to the left of -5, and the second function is defined to the right of 1, there is no x value that I can plug in this function. This f1 and f2 will not exist at the same time for any x value. Hence, h means nothing. Doesn't exist. So we have to determine the domain of each function individually, and then see if those domains overlap. If they don't overlap, this function cannot be created. It means nothing. You cannot plug in any x. It's not valid for anything. Good. So let's look at the first one, which is the square root of 7 minus x. And I would like you to give me the restriction, or how do I start. And then x squared minus 1, and I would like you to tell me what to write. So what do we need to write for the square root of 7 minus x?
7 minus x has to be greater than 0.
Greater or?
Even.
Yes. Indeed. This is not an index that is odd. This is an even index. Even indices are not friendly. They require the quantity under the square root or the fourth root or the sixth root to be greater than or equal to 0. If that quantity were in the denominator, I would have not been able to put it equal to 0, make it equal to 0 either, right? Just strictly greater than 0. But it's not in the denominator, so 7 minus x must be greater than or equal to 0. Perfect. Can anyone give us the restriction for the second one? Well, there's nothing different.
X squared minus 1 must be greater than or equal to 0.
Of course, right? They're all the same. As long as the index is even, the quantity under the radical has to be greater than or equal to 0. Perfect. Okay. So let's solve these two inequalities. What type of inequality is the first one? Is it exponential? Is it rational? Is it cubic? Is it
Linear.
logarithmic? I'm sorry?
Linear.
Of course. Linear. Very good. It's linear inequality. How do I solve it?
Add x to both sides of the inequality.
Okay, or subtract 7 from both sides, that's fine. And then divide or multiply by. Good. So we do what?
With the inequality.
Excellent. So this is the result of the first one. Hold on to it. We'll come back to it in a minute. Now, how do I solve this? Inequality, and first of all, let's identify what it is. We can no longer say linear, but we can say
Quadratic.
thank you. It is indeed a quadratic inequality. And now I'm going to ask you how we solve it. What is the next step? Before you say anything, I want to prevent. I like to prevent if possible, then cure. A note. Never take square roots of both sides of an inequality. So I want to prevent you from telling me move 1 and take the square root. That is not allowed in an inequality, please. Unless you're absolutely certain that both sides are positive, etc., always, forever. Otherwise, you cannot do this. So then there must be a way. How do I do it? What is the way? If separating the terms is not allowed for any inequality, I'm not talking about equations. You know, equation is a different story. But for inequality, you cannot take the square root from both sides. So then what do I do? How do I solve a quadratic inequality?
Do you expand it?
It is expanded. You're saying basically to factor it.
Yeah.
Good. So yes, we will factor. And this is my suggestion. I should have mentioned this when we started. I may show you methods that are different than what you studied before, and that what you may be still very comfortable with the method you studied or you know. I am never going to force you into using any of my methods. It's up to you. I'm showing you a method. I think it's the easiest, but you can say, no, I know an easier one that works for me. It's fine. But the only thing I'm asking you, if you can, just watch what I'm doing and then compare your method to this one. If you feel that this one is better, adopt it. If you think it's not better, do not adopt it. Okay? Is that okay? Is that fair? Okay. So x is the variable in the problem. X plus 1 is the first factor. X minus 1 is the second factor. And this is what I'm interested in, the product. Oops. I'm interested in the product, the sign of the product. Since I'm posting this later, I just want to make sure they're as clear as possible. Okay. So now I would like you to tell me, where is the 0 of x plus 1? Where is x plus 1 0? When x is
-1.
-1. Where is x minus 1 0? When x is perfect. Now please give me these two values in ascending order, and I will put them in ascending order. Perfect. For x plus 1, I will write 0 under -1. For x minus 1, I will write 0 under perfect. What will I write for the product under -1 and 1? Exactly, because one or the other is 0. So if x plus 1 is 0, the whole product is 0. If x minus 1 is 0, the whole product is 0. At this point, I need to study the sign of x plus 1 and x minus 1. What type of functions are these? X plus 1, what type of function is it? Is it exponential? Is it a trig function?
Negative.
Of course. Well, how does a linear function look like? Either this, with what kind of slope?
Positive.
Or this, with what kind of slope?
Negative.
Good. So what type of slope do these two have?
Positive.
So they come from which sign?
Negative.
Negative.
And they go to which sign?
Positive.
That's it. That's the sign. Of course, they cross the x-axis accordingly. And now I would like you to create a product when you multiply two negative numbers and tell me the outcome. Just the sign, of course.
Positive.
Very good. We're multiplying a positive by a negative.
Negative.
And we're multiplying two positives.
Positive.
Excellent. Now, this is the moment of truth. What do I want? What will I pick? When this product has what sign? What sign is greater than or equal to 0?
Positive.
Good. Is the product ever positive?
Yes.
For which x values?
Less than negative 1.
Excellent.
Greater than 1.
So now I would like to write this in interval notation. X in the interval.
Negative infinity.
Oops. Union.
1 to infinity.
That's it. So this is the method that I like to present whenever I show any type of inequality that is not linear. Quadratic, rational, etc. Have we finished? No, we haven't. We have two restrictions now. We have 7 to infinity, which is, I'm sorry, it's negative infinity to 7. Sorry about that. So negative infinity to 7. And we have negative infinity to negative 1, union 1 to infinity. What do we do with these two? So the first one is the domain of the first function, f1. The second one is a domain of the second one, f2. But I'm not really interested in either one. I'm interested in the function that is the sum of these two. So then, what do I do with all this information to find the domain of function h of x? Intersect. We will intersect those two. So I will have to intersect negative infinity to 7. There is no need for units here. I will have to intersect the purple region with the green one. I will have to pick the interval or intervals that contain both colors, both green and purple. And that will become the domain of function h. So what will I pick?
Parentheses negative infinity to negative 1, bracket 1 to 7.
That's it. And this is the domain of function h of x. A lot of work on this one. Why? First of all, because they were both radicals. Secondly, because the second one was a quadratic inequality that required some work, and I needed to explain what I'm doing. if you're comfortable with a different method, if you know a different method with a checkpoint and this and that, that's fine. You can use that. That's I mean, I accept any method that is a legitimate method. Now, what is more important is, do we understand this table? Is the table clear? Does it make sense? Because I'm going to use it, in studying derivatives and their signs, and when the function is increasing, decreasing, etc. So I'm going to use it again. I'm going to use this table again. Does it make sense? Do you have any questions about it? So I determined the zeros of each factor, and that's why the only numbers I needed were -1 and 1. And then I studied the sign. Since these are all linear factors, the only thing that can change is if I have a negative here, which means it comes from positive and going to negative. So the signs will be switched. That's the only difference. Only because these are linear terms, linear quantities. Okay? Good. Any questions? Moving on. Yes? Okay. The next problem, these are their examples in the book. They're asking you to pick blah, blah, blah. Well, this is not what I'm interested in, because basically this is not what we're going to do in this class, right? You're not going to get a multiple choice, just pick a graph. So don't even look at them. So we're going to analyze the graph from the beginning till the end. So I don't want you, this is not the purpose of the assignment, right? You have to work on the problem, identify later, not just say, oh, is it this, or is it that, or maybe it's this, maybe it's that. No, this is not, it's out of the question. No, this is not what I would like you to do. So y equals x minus 2 to the third power plus 4. It says graph without a graphing calculator. And I'm sure in some class before this one, in some course before Math 191, you studied the transformations. The transformations on basic functions. Transformations on basic functions. So which function at the core was, we find at the core of this function, which function was used to determine this? And we used two different transformations to create this function, but on which function? Yes, please. Very good. So the base function is x to the third. The first transformation in order of operations, what would that be? When we change x into x minus 2. So x minus 2 to the third power. What transformation is this?
Horizontal translation.
Yes, horizontal shift, perfect. To the left or to the right? To the right. Right 2. Do we understand why is to the right? Whenever we are changing x, we go left and right. Whenever we are changing y, we go up and down. How do I know I changed x? Because the base function was x, and here I have x minus 2. So the graph of x cubed goes through the origin. Well, this graph of x minus 2 will go to the right too. It's a horizontal shift of 2 units to the right. At x equals 2, the function is 0. It could not go to the other way, because it will be -2 minus 2, which is not going to be 0. Is that clear? Good. So right 2. And then transformation number 2 is on function number 1. And that is x minus 2 to the third plus 4. Now notice we did not change x. From x minus 2 cubed, it stayed x minus 2 cubed. Now the transformation is outside of x. So this must be a y transformation, because it's not on x. It's on the result. It's the overall. So what will this be?
A 4.
Thank you very much. Very good. So let's graph. We will graph the base function first, and this is something we should remember moving forward. This is x cubed. Notice that there are 3 solutions here. It repeats itself. It's 1, but there are 3 in there. That's why it crosses slowly. It's not this kind of cross. This will be 1 solution. It's this kind of cross, which is 3 solutions in there. It's x cubed equals 0, 3 solutions, although it's only 1. Okay, so this is x cubed. Then you told me to translate or shift to the right 2, 1, 2. So this is the graph now. So this is x minus 2 to the third. And then you said move the whole thing up 4. Okay. So 1, 2, 3, 4 up here. So this graph is x cubed minus 2, I'm so sorry, plus 4. It's already, we translated it. X minus 2 cubed plus 4. Now you can go in there, and if you want to select, because I guess you have to. Okay. Any questions on this problem? Any questions? Are we okay? Okay. Next one is y equals the square root of x. In the previous example, I didn't ask you anything about the domain because there is no discussion here. This is a polynomial. So, but here I'm going to ask you about the domain. This is not a polynomial. This is not a function that I like to call friendly. It's not really friendly. Okay, can anyone dictate a restriction that we have to write for this? Anyone?
X is greater than or equal to 0.
Right, we had, this is the third example, right, with the square root. Right? So the domain of this function is 0 to infinity. Do we remember the previous ones? See, that's why I'll write on the board. I can always go back right here. Okay? Yes? Good. So now let's graph. We can use a table. I prefer that. 0, 1, 4, 9, infinity. 0, 1, 2, 3. We're going to use this table a lot. We know how to graph the square root of x. It's not a big deal. 0, 1, etc. So this is the square root of x. Can anyone give us the range of the square root of x?
Bracket 0, infinity.
Very good. Perfect. Any questions on the square root of x? What if I want to graph the square root of x plus 1? What transformation is x plus 1 on the square root of x?
Horizontal translation to the left.
Exactly. Right. Very simple, because x plus 1 must be greater than or equal to 0, which means x greater than or equal to -1, and the domain is -1 to infinity. Of course, it's a horizontal shift of 1 to the left. Perfect. Any questions?